Welcome, my dear students. Today we'll speak about the Faraday's law of electrolysis. The quantity of electricity that is liberated, that is required to liberate the substance on one of the electrodes, whether it is a cathode or an anode. Here there is a very important relationship. We want to memorize it and we want to take it into consideration. It's very important in all the problems of electrochemistry or calculations. So this is this relation, quantity refers to the quantity of electricity equals the current intensity or the current strength measured in ampere multiplied by time in seconds. So the quantity of electricity in Coulomb equals the current intensity or the current strength I multiplied by the time in second. This is a very important relationship which we can calculate the quantity of electricity requires to separate, evolve, or deposit or liberate any of the substances on the anode or on the cathode. So here Faraday's two laws. The first law speak about the quantity of electricity which is required to liberate some substance on one of its electrode. What is the relation between the mass of the liberated substance and the quantity of electricity used to liberate this substance? Is it a relationship which is inverse relationship or a direct relationship? The second Faraday, if we pass electric current through an electrolytic cells connected in series, so there are different elements. What is the relation between the liberated mass of different elements with each other? If we have a cell with copper, a cell with silver, a cell with aluminum, so if there is any relation between the aluminum deposited and the copper and the silver deposited in the electrode, is there any relation? If the quantity of electricity is the same, what is the relation between the liberated substances, different substances on the cathode? So Faraday's first law refers to that the quantity of electricity is directly proportional to the liberated substance. How can we verify Faraday's first law? We can verify Faraday's first law if we form this cell, and here a silver nitrate electrolyte and silver electrode, and there is here the cathode. The silver will oxidize in the electrolyte and then reduced and deposited in the cathode. So the quantity of silver by mass in grams related to the quantity of electricity. So we have to record our observation, the quantity of electricity each time and the mass which is precipitated on the cathode, and make a relation. It is a direct relationship. As the quantity of electricity increases, so the mass of the deposited or liberated silver on the cathode increase, and this is the verifying of the first law of Faraday. So first law of Faraday means that the quantity of electricity used or applied in an electrolyte directly proportional to the quantity of mass that is precipitated on this electrode or liberated. Liberated here means precipitated, evolved, dissolved. Okay, so Faraday's second law refers to three elements or three cells which are connected in series. Connected in series means the positive pole of the battery connected to one and the cathode connected to the other, which is anode, the cathode connected to the anode, and this is the cathode which is connected to the negative pole of the battery. So positive pole of the battery connected to one electrode and the other negative pole of the battery connected to the last electrode. So this is aluminum cell, this is copper cell, and this is silver cell. So we pass the same amount of electricity in all these solutions. So what is the relation between the quantity of aluminum precipitated in the cathode and the quantity of copper precipitated in the cathode of the copper cell and the quantity of silver which is precipitated in the silver cell if the same quantity of electricity is passed through all these solutions? Okay, this is Faraday's second law. Faraday's second law states that as the equivalent mass of the element increase, the quantity of precipitated substance increase, and there is a mathematical relation, here. The mathematical relation like of aluminum, copper and silver. Okay, the liberated of the actual mass which is deposited or liberated at the electrode over the equivalent mass of the same element. This is a ratio and it equals all the ratio between the liberated mass and the equivalent mass of all other elements if they are connected in series. So the liberated mass or the actual mass over the equivalent mass of the first element equals the ratio between the liberated mass of the second element over the equivalent mass of the second element equals the liberated mass of the third element over the equivalent mass of this element. So what is the equivalent mass? The equivalent mass equals the atomic mass divided by the charge or the oxidation state of the ion. So the gram equivalent mass or the equivalent mass equals the atomic mass over the charge of the element atom or over the charge of the ion. So this is equivalent mass. Equivalent mass refers to the atomic mass over the number of charges of the element ion or the oxidation state or the oxidation number of the ion. So let's take some examples. Here we have chlorine and copper and aluminum. So chlorine, its atomic mass is 35.5. The mass of 1 mole is 35.5 grams. So what is the equivalent mass? So according to this law, it equals the mass or the atomic mass of chlorine over its charge, which is 1. So the equivalent mass here equals 35.5. Another here, the copper, the atomic mass equals 63.5, and copper, its common oxidation state is positive 2, so we have to divide the atomic mass over the charge of the copper. 63.5 over 2 equals 31.75, which is the equivalent mass of copper. Here aluminum, its atomic mass is 27. So what is the equivalent mass? Aluminum, its only oxidation state is positive 3. So equivalent mass of aluminum equals the atomic mass as a whole over the number of charges of aluminum, which is 3. In this case it equals 9. There is a definition of the equivalent mass. There is a definition of the equivalent mass. What is this definition? The definition of equivalent mass, it is the mass in grams which is equivalent, which is react with 1 mole. So 1 mole or 1 equivalent mass is the mass which deals with 1 mole. So here 2 chloride ions oxidized at the anode and releases 2 electrons. So 2 moles of chloride ions deal with or releases 2 moles of electrons. So how many of mass deals with 1 mole of electrons? So cross multiplication gives only the same number. It is the 35.5 here. And by the definition, not by the law, we can calculate all these elements. Like copper 63.5. 63.5 deals with 2 moles of electrons to be reduced at the cathode to form copper 0 solid. So this is the mass of 1 mole of copper. 63.5 deals with 2 moles of electrons. So what is the mass that deals with 1 mole of electron? The mass which deals with 1 mole of electrons equals the equivalent mass of the element. So this mass by cross multiplication equals 31.75. by law and by relation as by definition. So let's speak about aluminum. Aluminum by law, its charge is 3, so we have to divide atomic mass over the charge equals 9. Also by definition, aluminum positive 3 go to the cathode to be reduced, take 2 electrons, 3 electrons, and be aluminum 0 solid. So 1 mole of aluminum, which is 27 grams, deals with or reacts with or reduced by 3 moles of electrons. So in this case, we want to calculate the amount which is required for it to be reduced only 1 mole. This quantity as a mass is the equivalent mass which deals with 1 mole of electrons. So the equivalent mass of aluminum by cross multiplication, 27 grams reduced by 3 moles. So how many grams reduced by 1 mole? It is the equivalent mass by cross multiplication, gives also 9. Okay, so this is the relation of the Faraday's second law, and this is some simplification how this law is applied. So the atomic mass, here we have to we speak about how to verify the second law. The second law means that if the equivalent mass of the element increase, so the actual mass of the deposited mass increase. So there is a direct relationship between the liberated mass or the actual mass which is deposited on the cathode and the equivalent mass of this precise element. So we will connect the 3 cells together in series like this, and then pass through the electrolyte some quantity of electricity and measure the deposited aluminum here in the cathode and the deposited mass here in the of copper in the cathode, and here also the deposited silver by passing the same amount of electricity. We see that the amount of electricity have the ratios of 107.88 and 31.75 and 9, which are the equivalent masses. They have the same ratios. So at this time we verify Faraday's second law, as when we pass through these 3 electrolytes the same electricity or the same quantity of electricity, they liberate at their electrodes the ratios of the equivalent masses of these elements. So let's speak about some applications about the Faraday's first and second law and how we can use or understand the using of this electrolytes. So in passing this example or application, on passing 3 moles of electrons in 3 illustrated cells, this cell, silver, copper, aluminum, so what will happen, which are connected in series as you see, negative, positive. This is the cathode in case of silver, cathode copper, cathode of aluminum. Okay, so the mass of the deposited substances at the cathode of each cell would be as follows. We passing 3 moles of electrons. 1 mole refer to the equivalent mass. 3 moles, 3 equivalent masses of all these. So the first cell here, silver reduced by 1 electron, so 1 mole of electrons related to 1 mole of silver. So 3 moles of electrons related to 3 moles by cross multiplication. Here copper reduced by 2 moles. We pass 3 moles through these 3 cells. So 2 moles of electrons related to 1 mole of copper. So 3 moles of electrons related to how much? And we calculated it is 1.5 by cross multiplication. And in the same way, we can calculate aluminum. 3 moles of electrons reacts with or deposited 1 mole of aluminum. So the liberated amount of aluminum in this case when we pass 3 moles of electrons is 1 mole. So let's have some questions, some other questions. Okay, we have to omit this first. So example 1 here refers to a quantity of electricity, A quantity of electricity was passed through two electrolytes connected in series. The first electrolyte gold and the second contain copper. Gold positive 3 and copper positive 2. So this is the oxidation number to calculate the equivalent masses of copper and gold. So we calculate the equivalent mass of gold. We have to take the atomic mass over or divided by the number of charges to give the equivalent mass of gold. And the equivalent mass of copper, we have to take the atomic mass of copper and divided it by its charge to obtain the equivalent mass. Here, what is the question? He wants to calculate the mass of copper deposited on the cathode of the second cell. So here we can make the relation exactly of the second Faraday's law, and this equation or this relation, copper liberated substance over copper equivalent mass, is equal in ratio to the gold liberated substance over the equivalent mass of gold. So we have here the deposited mass of the first cell, which is gold, and equivalent mass of gold we will calculate from the atomic mass over 3, and that of copper, equivalent mass of copper, the atomic mass over 2, which is the number of charge. So here the copper liberated mass is required. The equivalent mass of copper can be calculated from this relation, and gold liberated mass is obtained, is given here, and the equivalent mass of gold can be calculated. There is another way to solve this problem. We can make cross multiplication. The equivalent mass of copper precipitated when the equivalent mass of gold is precipitated. So how much of copper will be precipitated at this amount, and make it like, if it is to some extent difficult, afterward we will write it. We will use a whiteboard and write it for you and solve the problems by writing. Okay, but it is very simple. You can divide the liberated mass of each substance over its equivalent mass, and you can put the numbers instead of these values, and you can calculate it easily. So this question here involves the calculating of the equivalent mass itself. How to calculate equivalent mass? So if we relate two elements with each other, and the same current of quantity of electricity is passed through the two solutions, okay, we can calculate what is deposited, what is the equivalent mass, if we know that the related masses of these elements. So here the question speak about copper and cerium, and there is a deposition of copper on one cathode of the electrolytic cells, and deposition of cerium on the cathode of the other electrolytic cell. So the question says that 12 grams of copper precipitated or deposited by the same amount of electricity of 14. So we can calculate the equivalent mass by this. Look at this. Deposited mass of copper over the equivalent mass of copper. Deposited mass of copper 12.7, and equals the deposited mass of cerium, which is 14, over the equivalent mass. From this relation we can calculate the equivalent mass. How can we the question is calculate the oxidation number of cerium. Calculate the oxidation number of cerium here. Calculate the oxidation number of cerium. So when we calculate the equivalent mass of cerium, we can divide the atomic mass of cerium over the equivalent mass of cerium to give the number of charges of cerium, or the oxidation state. We take that the equivalent mass equals the atomic mass over the number of charge. So if we divide the atomic mass over the equivalent mass will acquire the charge or the state or the oxidation state of the element. Okay. Another example. So here he asks about the quantity of electricity which results in evolution of 0.5 grams of hydrogen gas results in the same time at the same time to deposit the mass of copper equals how much? Look, here hydrogen, its atomic mass is 1 and its charge is positive 1, so the atomic mass equals the equivalent mass. This is half the equivalent mass. It will precipitate at the other electrode half the equivalent mass of copper. Okay, so what is the equivalent mass of copper? This is atomic mass and copper 2 sulfate. We know that the sulfate ion is negative 2 and copper in this case positive 2, so the atomic mass over 2 gives the equivalent mass of copper. So the amount of electricity which deposit the half amount of the equivalent mass of hydrogen will at the same time deposit half the amount of equivalent mass of copper. The equivalent mass of copper 63.5 over 2, which is 31.75 over 2, gives this amount, and this is the correct answer. Okay, now at this moment we finish our session. Thank you.